so number 10 says find the magnitude and direction angle for 4, -7. All right, so who remembers how to do this? You were supposed to do this last night. How did you find the magnitude and direction angle for 4, -7? Pythagorean theorem, that gives you your magnitude. So the magnitude is √65. Now this is the direction angle. This is going to be the actual answer where it says direction angle. But we're not going to find that one first. We're going to find this one first, right? And how do we do that? How do we find that angle right there? We use our calculators. What do we type in? Second tangent, right, we're going to type in second tangent, 7/4. And this angle is about 60.26. So how do I find the actual angle then? How do I get the actual angle? It's not 60. What do? Subtract it from 360. Kids, you have got to be able to figure this out. Stop and think. All the way around is 360, right? Did I go all the way around? I stopped here. How much short did I stop? 60 degrees? So I didn't go the full 360. I went 60 less than that. That's how we get this number right here. All right. Are V and U parallel, perpendicular, or neither? And the vectors are 3, 1, and -6, -2. Now, how do we do perpendicular? Which, by the way, orthogonal is the word. How do we do orthogonal? If what 0? If the dot product is 0. And how do we find the dot product? If the dot product is 0, they are orthogonal. And how do we find a dot product? X times X, so that would be -18. So that's -20. Are they orthogonal? No. We did not get 0. If they're orthogonal, we get 0, right? How do we tell if they're parallel or not? If they're multiples of each other, so you could say, all right, what do I take times 3 to get -6? -2? If I take -2 times 1, do I get -2? They are indeed parallel. They are multiples of each other. Now, if that confuses you, what is the slope of this vector? It goes over 3 up 1. So what would its slope be? No. 1/3. So the slope of this vector is 1/3. Y over X. What's the slope of this vector? -2 over -6. Is that the same as 1/3? If they have the same slope, they are parallel. So you can do it either way, whatever way makes sense to you. These vectors are parallel to each other. They have the same slope. And then finally, are these two equal to each other? So here's A and B. And here's C and D. And we want to know if they're equal to each other. Okay? So what are the coordinates of vector AB? Going from A to B. What are those coordinates? 3, 4. Kids, you gotta be able to do that. 1 to 4, that's 3 steps. You're seniors in high school. 3 to 7 is 4. So your vector is 3, 4. Now what about CD? Well, CD is, so what's the answer to the question? Are they equal to each other? Yes. Why or why not? Because they have the same coordinates. They have exactly the same coordinates. Now, we're going to start Prequest number 2. But first, let's get back yesterday's quizzes. These were 24 points, and we need to get these cleared up. So let's get the Wednesdays, yeah. Okay, did everybody get one back? All right, we're not going to go through this problem by problem. I'm simply going to ask you which ones you have a question about. So who has a question about a particular one of these problems? Does anybody have a question? Number 6, all right, let's start with number 6. Number 6, find the components of the vector. What do we mean when we say find the components of the vector? What are we looking for? X and Y. So we need to figure out the X and the Y for this situation. Now, how do we do that? Where are X and Y in this picture? I'm looking for X and Y. Where even are they? Make a triangle. And this is X and this is Y. And then how do I go about finding those? Cosine 59 equals X over 12. So X equals 12 cosine 59. And what does Y equal? 12 sine 59. So Moses, you just take out your calculator and you type in 12 cosine 59, and that's X. 12 sine 59, that is Y. Anybody else? Brittany?
If the direction angle is in the first quadrant.
If it's in the first quadrant,
Yeah,
then that's it.
Okay.
So like this would be 59 degrees. Period. Yeah.
Number 5.
Number 5.
Yeah.
How do we find a unit vector, kids? Yes, you do. We practiced it. Pay attention. How do we find a unit vector? First of all, we find the magnitude, and the magnitude of this would be
I know.
root 29.
Yeah, don't you just put 5 squared plus 2 squared under the radical?
Then you have 5 over root 29, 2 over root 29. So we divide our coordinates by the magnitude, and then we rationalize as necessary. So that's the final answer. So one more time. How do we find a unit vector? First of all, we find the magnitude with the Pythagorean theorem, and then we divide each coordinate by the magnitude. Jennifer? Number 7, we have -4, 2. So our magnitude is the square root of 20, or 2√5. That's our magnitude. This is the direction angle. So I need to find this one first. And how will I find that one? What buttons do I press to find this angle right here? I'm looking for this angle right here. What buttons will I press? Second tangent. 2 divided by 4. Remember, tangent is opposite over adjacent, y over x. So I'm going to press second tangent, 2 divided by 4, and it gives me 26.57. So now I got to figure out how big this angle is right here. It's not 26.57. This is 26.57. How do I find the measure of that one? 180 minus it. Because if you went all the way to here, it would be 180. We didn't go that far. We stopped here. So your direction angle would be 153.43 if I subtracted right. It doesn't matter. That's just going to give you a negative angle. You don't need the negative.
So if there's ever a negative,
Can that angle, that triangle be negative, Jennifer? No. So if you put the negative in, you drop it. But we use it anyway. All right, anything else on the quiz that we took on Wednesday? Anything else you missed that you're not sure why? All right, then let's get our Prequest number 2. Yep, we get our Prequest number 2, and here we go. We'll get started on that one. I have a few other old quizzes to get turned out.
You get your Prequest number 2 in the same packet?
Prequest number 2 now.
Alright. Prequest number 2. All right, let's start at the end and work our way up this time. So we're on Prequest number 2. We're on the back side. This looks a lot like Prequest number 1, doesn't it? A little bit.
Guess what else it looks like? The quest that you're going to take on Monday. Okay, it looks just like this. So the last question is going to be, are these guys equal or not? So we just did this. What is our strategy? If we want to know if these guys are equal, what do? We find the directed distance or the coordinates for both vectors, right? So what is the directed distance, or what are the coordinates for this vector right here, from A to B? What are we doing? How are we moving? -2. -8. -2, -8. We backed up 2 and went down 8, right? Now, what did we do for CD? -2. That looks good. Uh-oh. +8. What's the answer to the question? No. They are not equal. Why not? Their coordinates don't match. You have to both match. They don't match. So the answer is no, they are not equal. They do not match coordinates. Okay, now I have these two vectors. And this is number 11. And the question is, are they parallel, perpendicular, or neither? Okay, so we can do the dot product. Okay, so what's the dot product? I think they're called V and U. So what's the dot product? V dot U would be x times x plus y times y. I did not get 0, right? So that means they are not orthogonal. X times x, y times y, add them up. Now, how do I check to see if they're parallel? Are they multiples of each other? So if you want to do it that way, -2 times what will give you 4? -2. If you take 1 times -2, do you get 2? No, it doesn't appear they're multiples. Now, for some of you, that's just too confusing. You're not going to be able to figure that out. So do the slope. What's the slope of this vector? -1/2. Kids, for the last time, slope is y over x. If I'm going left 2 and up 1, my slope is -1/2. What is my slope here? Are they the same? No. So therefore, these are not parallel. They do not have the same slope. So the answer to the question is they are neither. This set of numbers is neither parallel nor perpendicular. Now I need to find the magnitude and the direction angle. So magnitude is easy. What's my magnitude? Square root of 5. How do I find magnitude? I do the Pythagorean theorem. Now, this is the actual direction angle. But we're not going to find that first. We're going to find this guy first. And then we're going to figure that one out. So how are we going to find that angle right there inside that triangle? Second tangent. Oh, that looks familiar. I got 26.57 again. Did you? Of course, if I'm the only one typing it in, you're not getting any practice, and then when you don't know how to do it on the quest, we'll know why. Anybody else get 26.57 for that reference angle? This angle inside the triangle right here? So what is my direction angle? How do I find this angle right here?
Subtract it from 180.
Subtract it from 180. So that's going to be 153.43 again. we need a unit vector in the same direction as this one. Okay, how do we do that? How do we find a unit vector in the same direction as that one? We need to find the magnitude of it first, so we'll do that with the Pythagorean theorem. So what is our magnitude? 5. And then what do we do with the magnitude? Divide each of these by it, right? And this time, there's not even any radical, so I don't need to worry about it. My answer is just negative 3/5, comma, 4/5. That's my unit vector. Got it? All right, number 8. Going backwards now, number 8. We want to find the components of the velocity vector. Okay, whenever it says components, I know what am I looking for? Coordinates, x and y. So let's draw a picture. Okay, this is an airplane problem. So we're going to structure it differently. And we're on a course of 218. So where do I put the 218 in this picture? Which quadrant? Quadrant 1, 2, 3, or 4? Quadrant 3. Here's 218. This angle is 218. And I know that the length of that vector is 410. And our job is to find x and y. So how do I don't even see an x and a y. What do I need to do here? I need to make a triangle, just like before. I need to make a triangle. And this is x and this is y. Now we've done enough of these. You know you're going to do sine and cosine, right? But you can't do that until you figure out what this angle is. You need to know the angle in the triangle. Right there. So now you got to use your common sense. How big is that angle right there?
72.
52 degrees.
But it would take 8.
Why is that angle 52 degrees?
Subtract 38 from 90.
If I went all the way up to this line, that's how many degrees? 270? But I didn't go that far. I stopped here, right? I only went 218.
Just do 270 minus 218.
Yep.
Yeah, that's what I did.
So that's 52 degrees. Now, if you figured out 52 a different way, that's absolutely fine. But you got to have 52. 52 is the angle. So then what do I do? Cosine 52 equals x over 410. So x equals 410 cosine 52. And what does y equal? 410 sine 52. Remember, x is always cosine and y is always sine. Now I type them in on my calculator and I get some nice little decimals. 252.42. And 323.08. And if I put that down, I get almost full credit.
What do I have to pay attention to? They are both negative. Why are they both negative? Quadrant 3. Look at the picture. X and Y are both negative, right? That will not happen automatically. You have to make it negative. Are there any question about that one? All right, number 7. We're going to write the switching gears now. We're going to write the parametric equations. So that means x equals and y equals. Not an ordered pair, though, not like this. It's an equation for x and an equation for y. And our points are 2, -1, and 3, 4. Who remembers how we start this? We have a thing we need to set up to get started. Do you remember what it is? We have a vector equation. What does that look like, Ashley? So this is the format, and now Ashley's going to fill it in for us. So what did you say goes here?
2.
Yep, your starting point. Right there. Just put your starting point right there. Now, I told you yesterday, and I'll tell you again, somebody on Monday is going to put this right here. And I'm going to mark it wrong, because that's not what goes there. What goes there? The vector from here to here. So we're going from 2 to 3, so that is a 1, and we're going from -1 to 4, so that is a 5. That's what goes in the second parentheses. How you get from point A to point B. Now we split it up. So what does x equal? 2 plus 1t. And what does y equal? There you go. That's it. There are your parametric equations. That's all there is to it. But you've got to remember this setup to get that ball rolling, okay? Starting point plus t times direction vector. All right, number 6. We need to remove the parameter and write one equation. Okay, so this is kind of the backwards now. We're starting with the parametrics. These are the parametric equations. But your job is to get rid of the t. Remove the parameter means get rid of t. So who remembers how to do this? Get t by itself. And doesn't matter which equation we do that in. No, so let's keep it simple. Let's do the bottom one. What does t equal in the bottom equation? Y minus 5. Now what do I do with the y minus 5? Plug it into the top equation. So x equals 2 minus 4 times y minus 5. And then I'll do my just normal distributive property carefully. Clean things up. Now I'm okay with leaving it like that, but some of you might like it better if you wrote it this way. It does not matter to me. The idea is you have no more t's. You have just one equation left, and you have no more t's. You've done your distributive. Any question about that one? Everybody good on that one? All right. Now we're going to find the angle between two vectors. Okay. Got to remember, we got to little formula for this too. Okay, we're gonna find the angle between these two vectors. All right, who remembers how we start? What?
B dot U.
Find V dot U. And we find V dot U, Moses, how?
Magnitude times magnitude times cosine.
Okay, now that's what V dot U is gonna equal, but how do I find V dot U? How do I get that number? How do I find the dot product? What do I do to find the dot product? X times X, Y times Y, add them up. So I get negative 10 plus 4, I get negative 6. Then, did you hear Moses? He said the dot product, which is negative 6, equals the magnitude of the first one times the magnitude of the second one times the cosine. So now we need to find the magnitude of the first vector. How do we find magnitude? Pythagorean theorem. So that's going to be root 20. Don't rationalize it, leave it alone. Remember, we're going to get two of them, we're going to put them together. How do I find the magnitude of the second vector? Pythagorean theorem, root 26. Remember what we do next? Put those together, get one radical, it's just easier. And then, then we divide, and what buttons do I press on my calculator? Second cosine. All right, so you need to do the first page. You need to finish the first page for Monday. We will go over that before we take our quiz. Have a great weekend.